As usual, we start by drawing a diagram representing the information that we've been given in the problem. Sphere A has a radius of 8a and sphere B has a radius of 4a. We're given that the weight of sphere A is 4 mg, and this will act downwards from the centre of mass. And similarly for sphere B, the weight is mg, acting downwards and centre of mass. We know that they are sitting on a rough surface, so in addition to a normal reaction force, there will also be a frictional force acting at the contact points between the sphere and the surface. For sphere A, I have labelled the frictional force as Fr and the normal reaction force as N. And for sphere B, I've labelled the normal reaction force as R and the frictional force as H. We don't need to know the directions that the frictional forces act in before drawing them on, because in our calculations later, if it turns out that we've drawn these in the wrong direction, we'll simply get a negative value for the magnitude of these forces. Where does two spheres touch at point C, they will each have a normal reaction force acting on them. This will be pointing directly away from the point of contact, at right angles to the surfaces of the spheres there. This means that these forces will actually be pointing towards the centre of each sphere. Here I've drawn them on as JA and JB, using a different colour to help you remember that these are equal and opposite. The subscript tells you which sphere these forces are acting upon. Because both of the spheres are rough, there will also be frictional forces between the two spheres. Again, these will be equal and opposite, so I've drawn these in as different colour and labelled them GA and GB. The question also states that at the top of sphere A, at point D, there is a force which I've labelled P, which has a magnitude of 2mg. In order to tackle this problem, we have to think whether you're going to look at each sphere individually or the entire system as a whole. Often you'll need to do both of these over the course of a problem. As the system is in equilibrium, we know that for any of these, the resultant force must be equal to 0, and the torque must also be equal to 0. It can be useful to draw a free body force diagram for just one of the spheres, like here for sphere B. As well as labelling the forces on it, you can also label other useful information that you might need to work out. For instance, here, the angle between the normal reaction force at point C and the horizontal, and a reminder that the frictional force and normal reaction force are at right angles to each other. In this question, the forces at the contact point C are unknown, so you have to think, is there a way of taking moments on this sphere without having to worry about the magnitude of these forces? Remember that the resultant torque is equal to 0 about any point. Now work your way carefully through this question in order to show that the force Fr is equal to 0.